Hi guys, this is Sohel and today I'll be solving the problem of the day. So let's move into it. Okay. So if you remember, we had done in the previous video what's an inorder. Okay. So we just need to return the root of the inorder successor. So here, as you can see, we will take left root and right. Okay. So this is the main root and there are two branches. The left branch will this one and the right branch which is 22. So firstly it will move to the left branch. Okay, so this is the leftmost one. So first 4, okay, then root, that means 8, then it will move to the right part. Okay. So in the right part, if we see, the leftmost is 10, then goes 12 and then 14. Okay, finally the root 20 and the right one 22. So we will be given a data that is set 8 here as said. So we need to print its successor. So if you see here, it is 4, 8, 10, 12, 14, 20, 22. Okay, so we will be printing 10 here. Okay, so what will we do is we have to return the note. That means this one, sorry, this one we need to return. Okay, so let's start the program. Okay, so firstly we will check if the root is none. So if the root is none, we will just return none. Again, it has been seen in the driver code that it's checking for none, so we'll be returning none. Okay. We can do something. We can just take a variable. We will be returning this variable. Okay, so we can initialize it with none, so that if none of the condition goes satisfied, then none will be returned. Now this is a binary search tree. Okay, that means, what does it mean is that, see here in the left side, the values will always be smaller than the root, and in the right side the values will always be larger than the root. Okay, and this means that the successor, inorder successor, will be greater. Okay, this will always be greater. So if you see here 20, then there comes a smaller value in the left side which is 8. In the left side here, smaller value 4 which is less than 8 here. Now this whole right side will have values which will be more than 8, because this is the right branch. Okay, so 12 which is greater than 8, 10 which is greater than 8 but it is less than 12, and 14 which is greater than 8 and 12 as well. Okay, and here we have 22 which is greater than this root. So we will first check. See, what will we do is, if we will take the root, so if root dot data, acha, this x, okay, you might confuse it for some integer value stored, but this is actually node. Okay, so we have to access the element with the help of dot data. So what will we do is, if root dot data is less than equals x dot data, that means if it is less, we need to move to the right side. Okay, so what will we do is, then we will let's say I have taken it in a variable tab. Okay, so or we can do something else, is that we can change the root. Okay, like root dot right, then it will move to the right part. Okay. Like if we have 8 and we are copying like root dot right, that means 12, so 12 will be stored in root. this one. If this is true, else if it does not hold true, then what will we do is we need to move to the left side. And see, when we are moving to the left side, we are encountering the successor, because see, in case of 20, okay, uh in case of 20, 20 is the successor of 8. Okay, 8 is the successor of 4. That means when we are moving to the left side from the root, that means the root will be the successor of its left side. Okay, so here we will be storing the root here, and we will be moving to the left side. Root dot, like root equals root dot left. Okay, we will be doing it. And another thing is that we will check while I need to control the indentation as well, while root is not equals to none. Okay, we will be checking this thing. Wait, I'll be now we are good with the indentation. Now at the end, what will we do is we will be returning this one, answer. Okay, which has the node stored in it, so we'll be returning it. Now let's run the program to see if it's working or not. First I'll compile it to check if there is an error. Okay, it doesn't have any error, so let's submit the program. Okay, so we have completed our program for today, and thanks for watching, guys.